Artificial intelligence, especially the ChatGPT, has taken everyone by the storm. Have have you ever wondered what exactly is running behind the scene of this ChatGPT and similar transformers? If yes, then you should be reading this research paper from OpenAI. I will be giving the link to this paper in the video's description, but let's go through this research paper in a bit of detail as it's quite fascinating. One of the key features of Kubernetes is that it's scalable and very flexible. OpenAI's ChatGPT and other technologies are one living proof of that. They have now scaled their underlying Kubernetes infrastructure to 7,500 different nodes. Previously, a few months back, they had scaled it to 2,500, and now, as the load has increased a lot, they have scaled it to 7,500 and still growing strong. In this paper, they not only give us their journey and their reasons why they selected Kubernetes, and also that their products like GPT-3, Clip, Delhi are using it, but also what challenges they faced. And also at the end, I will be discussing what is still unresolved, and if you want to help, you can help them too. Now, let's go through this fascinating research paper. First section discusses what sort of workload OpenAI is running. For example, they are not heavy on service endpoints and their workload is mainly geared toward IP to IP addressing. They are using NVIDIA's NVLink technology, which is mainly geared towards intercommunication between GPUs or by using GPU direct, but mainly through NVLink. And you can also check about NVIDIA's NVLink here on their website, which is mainly used for HPC and, as I mentioned, intercommunication, and very high speed one with a more bandwidth among GPUs. Apart from that, they also discussed as how much strain their cube scheduler was facing. So they need to come up with a solution because all of their pods were getting huge one-time spike, and then they were coming down at a relatively low rate. So, and then they mentioned something about biggest job, which run MPI, and also how their pods work together in a semi-stateful way. Also, they mentioned that unlike other organizations, they are not heavy on services, so there is no service endpoint, or there are few service endpoints, but not many. Plus, their pods interact with each other through SSH via pod IP, so there is not much pod communication happens through services. And then they discuss something about persistent volumes. Another cool thing which they mentioned is around networking. They mentioned that unlike many organizations, they were having issues with Flannel as they grew more. So instead of going with Flannel, they were going with alias-based IP addressing on their largest cluster, and they have more than 200,000 IP addresses in use at any one given time, which is fascinating. They also avoid encapsulation, and but that increases demand on their underlying SDN. Also, their network policies and traffic monitoring is very straightforward. There is no ambiguity there, which is great. And they heavily use IP tables, so which is a Linux primitive, and you can read more about it as what commands they are using and what options and flags they are using with IP tables. Also, for alerting and monitoring, they are using Prometheus and Grafana. Prometheus is a time series database, and Grafana has some alerting and dashboarding. And then there are various things and configurations they discussed about it. API server, as like in any other Kubernetes, is also a main feature in their own um, cluster, and they are very heavy on etcd key value stored too. And as I mentioned before, they use Grafana dashboards provided by the Kube Prometheus. And they monitor a lot of HTTP errors like too many requests or internal server errors with that. Also, their API servers are stateless, which is expected, and because of the load. Their API servers take a lot of memory, so they have to do some capacity planning there with um, in order to keep that strain under control. And then they share some graphs there. They're also using a bit of a Datadog cluster agent. And as I mentioned, for monitoring and alerting, they use Prometheus and Grafana. And then they go into a bit more detail as how they're using it, and which is quite cool too. They also shed some light around their health checks, which are quite passive, not really something groundbreaking there, but still a good read if you want to uh, read it from the lens of GPU testing. They also use quotas and resource usage because even with those 7,500 nodes, they just don't throw more hardware on it. They still use quotas and dates and tolerations, which is great just to control in like in any other cluster. One of this a balloon deployment really caught my eye. So they introduced a balloon deployment for both CPU only and GPU host. This deployment on their cluster contains a replica set with max size number of low priority ports. And these pods occupy resources within a node. So autoscaler doesn't consider it idle. And you can read more about it in this paper. Really fascinating read. And maybe you can even go with similar sort of balloon deployment in your own Kubernetes. Then they use gang scheduling because and for that they use co-scheduling plugin. As I mentioned, there are still few unresolved issues which they are working on, and if you want to contribute, you can. And most of these issues are around as they scale more, they are having issues with Prometheus built-in time series database storage engine, which is a bit slower. So you can work on it, or if you are more into the pod networking, you can contribute in that way. So I hope this was fascinating for you. As I mentioned, I will put the link in the video's description. I would highly suggest go through it if you work heavily in Kubernetes and are more interested in how to do more scale with your Kubernetes cluster. Any comments or feedback, please put them in the comments. Thank you.